Hi everyone, we're going to do three things to vectors. We're going to find the dot product, which is fairly easy. That's why I'm combining it with these part B and C. B, we're going to find the angle between two vectors. This is this formula here. It stems from the law of cosines. And I'm not going to go over the formal proof. So, also we're going to state if the vectors are parallel to one another, perpendicular to one another, or neither. So if they're parallel, then the angle between them is 0. And we know that cosine of 0 equals 1. So we're going to do a lot of examples, but if we get a 1, that means they're parallel, because that means there's 0 angle between them. Now, if they're perpendicular, that means our angle is 90 degrees. So, because cosine of 90 degrees equals 0, and that would mean they're perpendicular. For example, this would be 90 degrees up here. And we know that on the unit circle, cosine is 0, whereas sine is 1. Okay? So basically we go with some problems. If you don't know the dot product, I think you can learn it here because it's basically very easy. So the first one we're going to do is our vector is going to be I minus j, and our w vector is going to be I plus j. So simply, the dot product is just v dot w, and you're multiplying the coefficients or the scalars in front of them. So that's a 1, and this is a 1. So 1 times 1, and then you add the j components. So that would be negative 1 times 1, and that's going to equal 0. Now, when we do our formula to find the angle between them, we have cosine of theta equals, and I should have written, yeah, I did do that. Okay, so cosine of theta equals v dot w over the magnitude of v times the magnitude of w, and we already did those in another video. So basically we're going to get 0 over the square root of 1 squared plus negative 1 squared, okay, times 1 squared, square root of 1 squared plus 1 squared. All right, well basically we don't even need to do this because that equals some amount, but 0 divided by anything equals 0. So cosine of theta equals 0. All right, and the only way cosine of theta equals 0 would be cosine of 90 degrees equals 0. That means the vectors are perpendicular, but in vector land, instead of perpendicular, we're going to write orthogonal. Same thing, but we're going to use the word orthogonal. So, let me come over here. When I say perpendicular, I mean orthogonal. All right. Now, that's basically all we're doing, and we're going to do a few more problems. So, we're going to do v, vector 1, v is I plus j, and w equals negative I plus j. And when you do the dot product of this, v dot w, that's going to equal 1 times negative 1 plus 1 times 1, and that's going to equal 0. And then when you do the angle between them, we have cosine of theta equals v dot w over the square root of 2 times the square root of 2, which is basically 0 over 2, which equals 0. Now, it equals 0, so cosine of theta equals 0. That means my theta is 90 degrees. That means the vectors are orthogonal. And next time I'm just going to write orthogonal. But vectors are orthogonal, meaning they are perpendicular. All right. Yeah, all right. Now, the next one is, my first vector is 2i plus 2j, and my second vector, w, is I plus 2j. Now, let's do the dot product. The dot product is just going to be 2 times 1 plus 2 times 2. And that's going to yield 6. Now, I'm going to have to do my formula, cosine of theta, to find the angle between the two vectors is v dot w over the square root of 2 squared plus 2 squared, okay, times square root of 1 squared plus 2 squared. Now that's going to equal 6, because we already did the dot product, over square root of 4 times the square root of 5. Okay, so that's going to be 6 over 2 square root of 5. And when you fix this up, you're going to get 6 root 5 over 10, which equals, oh, this is 8, sorry. Let me fix this. This is 8. I messed up a little bit. So this is going to be 6 over 2 root 2 times root 5. Sorry about that. Which is 6 over 2 root 10, which is 3 over root 10. And if you rationalize the denominator, that's 3 root 10 over 10, which is approximately 18.4 degrees. Okay, since we have a value here that's not 0 or 1, that means the vectors are neither. They're not orthogonal, and they're not parallel. All right? The next one we have is 2i plus 2j, and my second vector is I plus 2j. Do the dot product, and I'm going to get 2 times 1 plus 2 times 2, and that gives us, oh, we already did that one. Oops, sorry. Let's do another one. So the next one, we'll do one more. The next one we have is v equals square root of 3i minus j, and w equals I plus j. So I'm going to do the dot product, and I get square root of 3 times 1 plus negative 1 times 1, and that's going to equal the square root of 3 minus 1. Now I'm going to do my angle between the two vectors, which is going to be my dot product. So that's square root of 3 minus 1 over the square root of square root of 3 squared plus negative 1 squared times square root of 1 squared plus, not square root, but just 1 squared plus 1 squared. All right, and that's all going to equal square root of 3 minus 1 over square root of 4 times the square root of 2, which equals, this equals 2, so we get square root of 3 minus 1 over 2 root 2. And clearly this, if you put that in the calculator, you're going to get 75 degrees. So your theta equals 75 degrees, so the vectors are neither. All right? Let's do one where they're orthogonal. All right, so we'll do a couple more. Let's say V equals 4i and W equals J. So we're going to do the dot product. Basically, we can rewrite these as 4i plus 0j and W equals 0i plus j. And then we do the dot product, and we get 4 times 0 plus 0 times 1. That equals 0. And then when we find the angle between them, we're going to have 0 over something, these square roots, and that's all going to equal 0. So that means my angle equals 90 degrees, and that means they're orthogonal. And I think that's good enough. The next video we're going to be doing is decomposing V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. So we're going to decompose vectors. Have a nice day.